Part 1. The test with strict exogeneity gives us rho hat equal to minus 0.097 and a t-value of minus 2.41. The regression that includes growth of minimum wage and growth of CPI gives rho hat equal to minus 0.098 and a t-statistic of minus 2.42. Roughly the same t-values and rho hat value. Therefore, we find evidence of some negative serial correlation, and it does not matter which form of the test we use. This is the regression equation for part 2 and 3 with 3 types of standard errors. Note that the estimates are not changing, only the standard errors change. The first line of standard error is the OLS, the usual and probably incorrect type. The second line is the Newey West standard error type, and the last line is heteroscedasticity robust standard errors. We have over 600 observations, and the R-square are the same for 3 types of standard errors, which is 0.293. So comparing the Newey West standard error and the usual OLS standard error for the variable growth of minimum wage, we find that the Newey West standard error is much larger than the OLS one, roughly 4 or 5 times larger. But for the variable growth of CPI, the Newey West standard error is actually smaller than the OLS one. That is the answer for part 2, and for part 3, we consider the heteroscedasticity robust standard error with the Newey West standard error. We don't find much difference. So the difference between the 2 types of standard error is that the last one only controls for different variance of the error terms. That's why it's called heteroscedasticity robust. But Newey West standard error does more than that. The Newey West standard errors are robust to both heteroscedasticity and serial correlation. As we find little difference between the two, it's probably because the negative serial correlation. Adjusting the standard error on CPI actually reduces it. Heteroscedasticity does not have a major effect on the growth of CPI standard error. That is part 3 and part 4. We run a BP test. We get F statistic equal to 33.8, which means the p-value is almost 0. There is a very strong evidence of heteroscedasticity. Part 5. The usual F-test is 4.53 with a p-value of 0.058. So in the static model, using the heteroscedasticity robust t-statistic led to a less significant minimum wage effect. Okay, actually this is for the usual F-test. And this is the heteroscedasticity robust test. Right. So the heteroscedasticity robust test for the lags show a very strong significance of the wage effect. Part 6. The Newey West version of the F statistic is about 7.79, which show even more statistic significance than just the heteroscedasticity robust statistic. So adjusting the F stat for heteroscedasticity or heteroscedasticity and 12th order serial correlation leads to the conclusion that the lags are very statistically significant. Part 7. With 12 lags, the estimated long-run propensity is about 0.198, and without the lags, the estimated LRP is just the coefficient on the growth of minimum wage. Which is 0.151. So when we include the lags, LRP is about 30% larger. Using the Newey West standard error, the 95% confidence interval for the LRP is from 0.111 to 0.284, which easily contains the estimate from the static model.